for aldehydes.
1 degree alcohol. Yeah. From alcohol, 1 degree alcohol from aldehyde.
Aldehydes, sir. Yeah.
Okay. Is it like always 1 degree from the aldehyde?
I think so, sir. Like, yeah.
It depends.
Yeah.
It depends. Smart, is it always 1 degree alcohol we form from carbonyl group or aldehyde?
Sir, aldehyde, we can use formaldehyde, we won't get 1 degree.
No. In case of formaldehyde, we get 1 degree. In case of any other aldehyde,
Sir, but using LiLH4,
using
LiLH4.
LiAlH4, lithium aluminum hydride.
Yes, sir, for formaldehyde.
Yeah, in that case, it depends what is given. But example, how you compare in case of Grignard reagent, isn't it?
Yes, sir, for Grignard, minimum 1 degree.
Yeah. So here, example, it depends what kind of molecule you have. So if you have normal aldehyde, you will usually get the primary alcohol,
Yes, sir.
correct? You will usually get the primary alcohol, always. Then, Chinmay, what are the reducing agents?
Sir, mainly we use NaBH4 and LiAlH4.
Okay, other than that, correct?
And then we can use platinum, palladium, nickel, or anything, sir.
Along with, these are the catalysts. Along with
Along with this thing, sir, H3O plus and H3O plus and yeah,
H2O
H3O.
plus or a hydrogen gas.
Yeah, hydrogen gas, any one of them.
So this is known as catalytic hydrogenation. This
Yeah, sir.
process of adding hydrogen along with a finely divided nickel, platinum, or palladium, it is known as catalytic dehydrogenation. Sorry, hydrogenation. Because we are using catalyst and then we are adding hydrogen. That's why catalytic hydrogenation.
Yeah, sir.
Then Smart, if you take alkyl halide and then add lithium aluminum hydride in it, what will be the product?
So do we get alkanes, sir?
It will form alkane. How this lithium aluminum hydride will break?
Sir, AlH3 and Li plus.
AlH3, Li plus and
H minus.
H minus. So this H minus will go to which site? Oxygen or carbon?
Carbon, sir.
Carbon. And Chinmay, if you are using H positive from water, then where this H positive will go in case
Sir,
of
OH.
carbon?
OH minus.
Oxygen.
Yeah, sir, oxygen.
Correct. So, smart example, if you take any ketone
Yes,
and
sir.
then you take lithium aluminum hydride plus with D positive, what will be the product?
Sir, OD.
OD. And Chinmay, if we take sodium boro deuterium and H positive ion, then what will be the product?
Sir, we'll get OH and deuterium, sir.
Yeah. Samarth, if we take carboxylic acid along with lithium aluminum hydride, so what will happen?
Sir, with carboxylic acid.
Yes, carboxylic acid with lithium aluminum hydride,
We'll get alcohol, sir.
alcohol. So that is the thing. When we are preparing alcohol, we said first method is from alkene, whether acid catalyzed hydration, hydroboration oxidation, oxymercuration, and demercuration. There were three methods from the alkene. Second is carbonite. If you have aldehyde ketone, then catalytic hydrogenation or sodium borohydride will give you alcohol. But if you have carboxylic acid, you need lithium aluminum hydride. a strong reducing agent to make it happen to form alcohol. Chinmay,
Yeah, sir.
if you have carboxylic acid and you don't want to use lithium aluminum hydride, what will you do?
Sir, we can do esterification, sir. We can add R dash
Very
OH
good.
and then
Uh,
remove water,
uh,
and then we'll get R C double bond O R dash, and then in the presence of hydrogen and catalyst, we can get
hmm.
1 degree alcohol and RCH2OH, ROH, yeah, R dash OH.
So what is the advantage of this reaction?
So your advantage is like it is less expensive because we are not using LiLH for
And what is the
economically.
disadvantage?
So disadvantage is we are getting two products, sir, which is then difficult to purify. Like we are using, yeah, sir. I don't know, sir.
Okay. Smarth,
Yes,
what
sir.
is the disadvantage of this reaction?
Sir, we are using alcohol to again get alcohol.
Actually, disadvantage is I didn't mention yesterday. Um, remember this carefully. It is a reversible process. It is a reversible process. Okay. So in that case, what you have to do, you have to add more reactant or you have to keep removing product because you know Lee Chatelier principle, right?
Yes, sir.
L- Um, let me revise what is the Lee Chatelier principle. It says if any reaction is reversible or equilibrium, then if we are forming product, then reaction can also form reactant again. So you will not get real product. They will keep changing in one form to another form, reactant to product, product to reactant. To avoid this process, we have to understand what to get. Example, if you want to get more product, so there are two possibilities. You add more reactant, so it will form product, or you remove product, so there will be shortage of product and more product will form. Chinmay, any doubt?
No, sir, understood.
Samarth, any doubt?
No, sir.
So this is the simplest way of Lee Chatterley principle, which tell us what could be the situation when reaction is in equilibrium. Remember, this is the criteria equilibrium. Then you want to decide whether you want to take this process to the forward or backward. Sumanth, what is contact process?
Sir, in which the same reagent is used to produce more of itself. Right?
No. Chinmay, what is contact process?
Sir, it's the process of preparing H2SO4, sir.
Yes. So
Sir,
Samarth, it is for H2SO4. That is one of the utilization. Got it?
yes, sir.
But I said ki if you take small amount of the same material and you are producing more, that is one of the part of the contact process.
Okay, sir.
Same thing happen in the esterification, right?
Yes.
So what is the intermediate in the contact process? What?
Oleum, sir. H2S2O7.
H2S2O7. Chinmay, if you take acid amide and use lithium aluminum hydride, what will be the product?
Sir, we'll get RCH2NH2 and then water.
Yes. And if you have smooth acid anhydride, acid halide, ester, if you have any of these options,
Yes,
and
sir.
then you take lithium aluminum hydride, what will be your product?
Sir, alcohol. In case of acid anhydride, we get one acid and alcohol.
Yes. Everywhere you will get alcohol except acetamide.
Yes, sir.
Chinmay, if you want to make alcohol using Grignard reagent, what will be the reaction?
Sir, so we take any carbonyl compound
Okay.
and then we add Grignard reagent MgX, and
Hmm.
then we'll get alcohol plus MgOHX in the presence of water, sir. H2O will get
In
added.
presence of correct.
Yeah.
Smart, if you have formaldehyde, in case of carbonyl, if you have formaldehyde, what will be your product using
The
Grignard reagent?
primary alcohol.
Sinway, if you have any other aldehyde except formaldehyde, what will be your product?
Sir, it should not be 1 degree alcohol. Like other than formaldehyde, any other aldehyde, I think
Uh,
so. It will be not it won't be 1 degree alcohol, sir, because aldehyde will get 2 degree alcohol.
yes, it will be 2 degree,
Yeah, sir.
only 2 degree. And Smart, if you have ketone,
The 3-degree alcohol.
3 degree. Sinway, if you have ester, what will be your result?
Ester, sir.
Yes,
Don't know, sir.
Smart.
The ester, we again get 2-degree alcohol.
We get 2 degree alcohol, but remember we have to use Grignard reagent twice.
Yes, sir.
First time you will get aldehyde, and then aldehyde will undergo same Grignard reagent. So secondary. So you may remember this. If
Yeah,
you have ester, first product will be normal aldehyde,
yeah, sir.
and then normal aldehyde you already know how to do the further process for alcohol, right?
Yeah, sir.
Yeah. So this is the two-step process kind of. Smart, if you have epoxide, how will it break? What is epoxide?
The epoxide is a compound which has a ring formed with oxygen.
Yes, ring formed with oxygen. And what will be the product
The
in along with the Grignard reagent?
less stable first degree alcohol. It depends
First
on the
degree alcohol.
structure of epoxides.
Yes. So in case of epoxide, what will you see is that bond between the carbon and oxygen will break, and then it lead to the formation of alcohol. Where is this? Say this. Is this visible?
Yeah, sir.
Bond between carbon and oxygen will break. So R will attach to the carbon, and MgX will attach to oxygen later on. It will be alcohol. Chinmay, if you add oxygen along with the Grignard reagent, what will be your product?
Sir, if we add oxygen,
Hmm.
again we'll get ROH only, no, sir.
Yes. If
Yes,
RMGX is added, you will get ROH, but two
ROH.
times.
Yeah, sir.
You have to take RMGX 2 times. See,
2 times in the
first time
presence of
oxygen will
water.
be added in between, then again RMGX, so two molecule will form, and ultimately ROH.
Yeah.
And then, Smarth, what is oxymercuration, demercuration?
We're adding mercury to get alcohol and then removing mercury.
Correct. Chinmay, hydroboration, oxidation.
Sir, hydroboration oxidation is when we can take any alkene in the presence of
Hmm.
diborane to get 1 degree alcohol and boric acid, sir.
Yes. And Smart, is it a really good reaction, hydroboration, oxidation? Do we get good yield, and which rule is followed here?
There are anti-Markovnikov's rules.
Anti-Markovnikov rule is followed, and do we get good amount of yield?
Yes, sir.
And what is the role of H2O2 in this case?
Sir, it oxidizes.
Oxidizing agent.
Yes, sir.
Chinmay, what is acid catalyzed hydration reaction? I will make it.
Sir, yeah, sir, we can take any alkene which can undergo hydration in the presence of
Hmm.
H2SO4, which can give alcohol, sir.
So what is the role of alcohol in this case?
Sir, what is the role of?
H2SO4 or acid in this case?
Sir, does it act as a reducing agent?
No,
No, oxidizing agent. Sorry, yeah.
no.
Don't know, sir.
Chinmay, Smarth,
Sir, catalyst?
it acts as a catalyst, Chinmay.
Okay, sir.
That's why acid is acting as a catalyst and there is a hydration process, addition of H2. Got
Okay,
it?
sir. Yeah, sir.
Then what do you mean by rearrangement? When does it happen, Smarth?
Sir, when there's a possibility of more stable carbocation.
Yes, carbocation with more stability. Chinmay, if you have alcohol, phenol, and ether, in which condition you have more angle and why?
Sir, in which we'll have more?
Bond angle and why?
Sir, is it phenol, sir?
No,
Don't know, sir.
Smarth,
Among which one, sir? I couldn't hear.
alcohol, phenol, and ether.
Alcohol, phenol, and sir, ether will have highest one.
Ether will be highest. Why?
Sir, because alkyl group is slightly electron donating.
Alkyl group is slightly electron donating. That is correct. What else?
It sends electron pairs towards oxygen, sir. And
Right.
oxygen has
What
two
are the
lone
other
pairs.
reasons? What else? There are other reasons also.
So, steric hindrance among alkyl groups.
Correct. Steric hindrance repulsion between the alkyl group will cause this. In case of phenol, electron-electron repulsion.
Yes, sir.
Chinmay, if you see the bond length in case of alcohol and phenol, where
Yeah.
will you have more bond length?
Between alcohol and phenol.
Yes,
Sir, I'm not sure. Sir, is it phenol, sir? Because
because of
a phenyl group will have a pi electron cloud, which will repel lone pair present on oxygen.
that is responsible for the more bond angle. What you
Yeah,
said is applicable for bond angle.
bond
I'm
angle.
asking about bond length.
Sir, bond length, don't know, sir.
Smart
Sir, partial double bond character due to resonance effect.
partial double bond character will be responsible for reduction in the bond length. Last
Okay.
question. What is dehydrohallucination reaction, Chinmay?
Forgot, sir.
Dehydrohallucination reaction.
Oh.
Dehydrohallucination reaction. What does name signify? It's okay if you forget. But what does name signify?
Sir, yeah, sir. So, chemical reaction where hydrogen and halogen is removed, which will
Correct.
form,
So what could be the possible reactant?
sir, alkyl halide.
Exactly. Alkyl halide is the possible reactant. And now you are removing
Yeah, sir.
hydrogen and halogen. What could be
So
the
we'll get,
possible product?
yeah, sir. So we'll get alkene.
Exactly.
Yeah, sir.
What I'm trying to convey, Chinmay, even you are not sure, just based on the name,
Yeah,
could
sir.
you relate?
Yeah, sir. Yeah, sir.
Right? So
Yeah.
alkyl halide is forming alkene by using which chemical? That is fine if you are not able to remember this.
Sir, alcoholic KOH.
Alcoholic KOH. And which
Yeah.
rule is applied here?
Sir, it acts as a base.
Yes, it acts as a base, but which? rule is applied here? There is a famous rule.
Don't know, sir. Forgot about it.
Smart
Sir, Sajef.
Shade-Jeff rule.
Yeah.
Shade-Jeff rule. So Chinmay, what does this Shade-Jeff rule say?
So yeah, sir. If two different alkenes can be formed, the major product is that alkene which has more number of alkyl groups attached to CC double bond.
So more alkylated group will be more stable, right?
Major product, yeah, sir.
Yes. So now you tell me, both of you, if you have a gap between the classes, do you feel you tend to forget a lot of content? It does not mean you don't know. It's just you tend to forget what is the reaction,
Sometimes, sir.
Yes, sir.
right? So that's
Yes.
why make sure always and like regularly attend the class. Even if we have 1 or 2 week break, we'll forget many things. And did you feel, both of you, key if you are attending this class, you don't need to revise a lot in home. You don't need to work a lot in home about the chemistry.
Yes,
Yeah.
sir.
Yeah, that is what that kind of environment I want to create. Key everything will be revised here in the class. After that, you just need to focus on the other subject, and then you can do well in other also. Because I want to give you time. Example, you can't study here, then study chemistry in home for 2 or 3 hours, then you won't have time for the other subject. We have to strike balance between all, right? It's like you are finishing most of the things here only, and then you are focusing on the other subject. Make sense?
Yeah. Yeah, sir.
Uh, Today's date 21 or 22?
21, sir.
22, right?
22, sir. Yes.
22, sorry.
22. And we started at 1:30, correct?
Yes, sir.
Okay, so alcohol preparation is done. Phenol preparation is quite easy, and we are not doing many extra stuff, so we'll make it fast. Sinme, tell me what are the uh, different method to prepare the phenol. Before that, uh, as you already know this thing, okay, we'll do it later. We'll combine alcohol preparation and phenol preparation together in the end of the class. Okay, let's start with
Okay,
the
sir.
phenol. Chinmay, what are the different methods of phenol preparation?
Yeah, sir. So first we can prepare phenol by chlorobenzene, sir.
Hmm.
From chlorobenzene, yeah, sir. So chlorobenzene, then with NaOH,
Uh,
will give sodium phenoxide, and then when
Correct.
it is passed through HCl, then we'll get phenol.
And what is the name of this process?
Uh, Forgot, sir. What is it?
It starts with D.
Sir, it starts with
D and with the W.
sir dose process.
Dose process, correct. And Smarth, other method of preparing phenol,
Sir, from diazonium salt.
isonium salt. Okay.
Uh,
And what
we ha
happened in isonium salt?
Sir, first we make diazonium from aniline with
Uh,
MnO2 and HCl.
uh,
Then we get diazonium salt, we heat it with water.
okay. And Chinmay, what are the other methods?
Yeah, sir. We can also prepare phenol from benzene by sulfonation of benzene.
Sulfonation of benzene. Okay.
Yes.
And last, Smarth, what is the last method?
Sir, I don't remember process. I know from cumene also we can make phenol.
Correct. So what happened in cumin?
Sir, I don't know that.
Chinmay, what happened in case of cumin?
So yeah, sir. So cumene we take, and then first step in the presence of oxygen and temperature should be around 100 to 130. degrees Celsius, we'll get cumene hydroperoxide.
Correct.
And then second step, cumene hydroperoxide in the presence of H plus ion and water will get phenol and acetone.
Correct. So as both of you know most of the thing, let's not write all equations separately and we can directly make summary if both of you agree. Correct?
Yes.
No need to like write every reaction separately, just one summary. Smart, we call phenol as carbolic acid. Why?
Sir, even though it has OH group, it acts as an acid more than.
Yeah, because of the acidic nature.
Yes, sir.
Even though it is containing OH group, but what is actually happening in this case? In case of phenol, this can easily release as positive ion and it will act as a phenoxide ion, right? So that's
Yes.
why due to the acidic nature, it is also known as carbolic acid. And first time it was isolated from coal tar. And nowadays we are making from the different method and I'll directly write summary. So result is phenol. Chinmay, you told me dose process. So Smart, you tell me what is dose process.
Sir, using extreme temperature and pressure conditions to form stable
Ah,
aryl carbocation.
okay. And what is
623
this
Kelvin on
extreme?
300 atmosphere.
Yes. Very high temperature 623 Kelvin and very high pressure 300 to 320 atmospheric
Atmosphere.
pressure. And Chinmay, what is the one atmospheric pressure equal to
Sir, in terms of
in terms of Pascal?
uh, sir, in terms of Pascal, not sure, sir.
Smart
Sir, 1.01 into 10 power 5 Pascal.
1.01 10 to the power
5.
5 Pascal. Okay, so one atmospheric is equal to 10 is to the power 5 Pascal approximately.
Okay.
What is one bar, Chinmay?
1 bar, sir.
Yes.
Uh, don't know, sir. I forgot.
Smart,
Sir, 1 atmosphere.
no. One atmospheric and one bar, there is a difference. Which one is bigger?
Sir, 1 bar is 76 centimeter of Hg.
Which one is bigger? One bar is bigger or one atmospheric is bigger?
Sir, is it 1 bar, sir?
No.
Sir, I
Though
thought they were
they
same.
are very close to each other, but what you need to remember is one atmosphere is a bigger unit. One atmosphere is equal to 1.01 bar, slightly bigger. So they are not same.
Okay.
Okay. So both of these units are not same. One atmospheric is bigger unit compared to the one bar.
Sir, what is torr?
Torr is again unit of the pressure and that is equal to 760 mm or 76 centimeter.
Sir, 1 torr is
Okay,
equal to
so
76 centimeter.
yes, so that is one torr and again the unit of pressure. It is also equal to 133 Pascal. If you take in the Pascal because Pascal is the standard unit, SI unit. So one torr is equal to 133 Pascal, 760 mm of Hg, or 76 centimeters. These unit will also help you to understand this. What is the chapter name? What
Fluids.
is the fifth chapter in the chemistry? 11th class?
Thermodynamics.
No. Thermodynamic in the new syllabus, but according to the old syllabus, gaseous state. In
Oh,
gaseous state, you have this in your syllabus. Okay, I will write it here. Otherwise, you forget. So, 1 atmospheric is equal to 1.013 approximately bar, and both of them are approximately equal to 10 raised to power 5 Pascal. It can be given in the form of torr. 1 torr is equal to approximately 133.3 Pascal, or equal to 760 mm of Hg, or equal to 76 centimeter of Hg. This will also help you in the physics when you are doing the fluid mechanics. Correct?
yes, sir.
So we should always correlate like this. Third method was disonium salt. So can I take directly disonium salt instead of
Yes, sir.
taking aniline?
Yes.
So if you take disonium salt, just simply add water and heat it. Then you will get the phenol. Got it? But if you want to make it from the aniline, then you know nitrous acid you have to add. Sinhmar, what is the formula of nitrous acid?
Sir, NaNO2 plus HCl.
Yes, NaNO2 plus HCl is known as nitrous acid. Is this sufficient to make this reaction happen, Smart?
Sir, temperature we should maintain 0 to 5 degrees Celsius.
Why?
Sir, at higher temperature,
Hmm.
it gets even unstable, sir, like the diazonium.
Why?
Sir, because like the tendency of N2 to form more stable gas.
Exactly. Tendency of N2 to form more stable gas. That's why this is unstable. What is this compound name, Chinmay?
Sir, this is cumene, sir.
Cumene. So can we call it as
Isopropyl benzene.
isopropyl
Yes.
benzene, or can also call it as cumene? So as you mentioned, ki if you add oxygen in it, so it will, what should be the product, Chinmay?
Sir, cumene hydroperoxide.
Is this correct?
Yeah,
What
sir.
is the
That's
peroxide meaning, Chinmay? Smart.
The OO bond is there. Oxygen is in -1 state.
Yes. So in peroxide, oxygen is always present in the -1 state, and after that, you will add acid, any acid along with the H2O. So your product will be phenol. Chinmay, what will be the another product?
sir, acetone, sir.
Acetone. By the way, remember, acetone is also producing large quantity. So you can use this reaction to produce even acetone. So you will always remember phenol is produced from the cumene. But remember, even if you want to produce acetone, you can use this method. And this is cumene peroxide. Now, so we have finished the preparation of the phenol. Got it? So
Yes, sir.
you are already aware about this, so that is a good thing. More you read, more quickly will do. Chinmay, if you use, I'm taking NCRT example. If you are making this, what is the reagent required for this?
Don't know, sir. Not able to.
Smart.
Sir, borane, sir.
What?
Sir, borane, like from hydroboration oxidation.
Hydroboration oxidation. Yes, that is one method. You can use hydroboration oxidation. What else? That is what I'm looking for, key diversity. You can use H2O2, diborane, and if you take this reactant CH3, C, CH3, double bond, CH2, you can make. What else? Chinmay, what else?
Don't know, sir.
Because in conversion, you will always have choice.
Sir, we can use
Always have choice.
aldehyde.
What?
Sir, aldehyde.
Aldehyde, CH3, CH2, CHO. It could be carboxylic acid also.
Yes, sir.
So alkene is done, carbonyl is done. What else? One more. If you take HCHO, and what will you add in the RMGX form? So you can
Sir,
get this.
secondary, the Grignard reagent of secondary halide.
Will it be this?
Yes, sir, 2-propen. Yeah.
Actually, in the question, this was asked, what will be the other reactant along with the methanol? This was the answer. But as I always mention, we should explain if we are using different method, how we can prepare it. Chinmay, next question for you. If you have this, and trust me, this question can be directly asked in your CT and JEE. Very, very, very popular. Chinmay, what will be the answer?
Don't know, sir. Not sure.
What is the role of sodium borohydride? What is the role of sodium borohydride?
Reducing.
Yeah. So if you consider this Chinmay, only this part, what should be the possible product? Ketone. And using reducing agent like sodium borohydride.
So phenol.
Phenol.
Yeah, sir.
So can we say we can form this product? Not exactly phenol because this is not benzene, right? But what you were trying to say, ki here it will be OS, right?
Yeah, sir. Yeah, I told you then
This is
POI.
what will happen to this. This is critical.
Don't know, sir. Not sure.
No idea.
This, and that's why this question is very special for J and mark this very, very important for J.
Sir, it will be less reactive.
It won't react. If you remember, I told you hydroboration oxidation. That's why we were taking more time. I said If this sodium borohydride act only for aldehyde and ketone, not for any other thing. See, here we have carboxylic acid, here we have acid halide, here we have acidamide, here we also have ester, but only for the sodium lithium aluminum hydride, not for sodium borohydride.
Oh.
And that's why this is very popular and important question for your exam. So it will remain same. Got it? Wasn't it done in your class?
I don't remember.
But this is very, 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 very popular. That's why I especially mention only this point. Just give me a minute. Hi, ma'am.
सर माइक्रोब्लॉग ठीक है मुझे ये पूछना था कि आप क्या चार्ज करते हो ऑनलाइन क्लासेस के
मैम एक बार क्लास अटेंड कर लेते हैं, अगर बच्चा कंफर्टेबल होगा उसी हिसाब से हम प्लान कर लेंगे। चार्जेस का इश्यू नहीं रहेगा, अगर बच्चा अच्छा रिस्पॉन्ड करेगा ना तो वो इतना बड़ा इश्यू नहीं है मेरे लिए। बट बच्चा एंजॉय करे और बच्चा सीखे तो उसके हिसाब से हम प्लान कर लेंगे।
ठीक है सर तो 5 बजे का रख देते हैं ठीक है ना
ठीक है मैम, श्योर।
ओके
ओके। Yes, guys. Example, other question are extremely easy. What is given in your NCRT? Very easy. See, like you will do without even asking this question. Ki, this is the CH3, CH, double bond CH2. When you add H2O and acid, what will be the product? Oh, each of you tell me the answer. CH3, CH2, CH, CH3, CHO. If you take sodium borohydride, what will be the answer? Tell me one answer. Smart first answer, third.
The 2-propanol.
Exactly. Sinhmar, this answer.
Uh, sir, don't know, sir.
Will
Sir,
it be
is
this?
it glutenol?
CHO convert into CH2OH because sodium borohydride is reducing it then. Correct?
Yeah, sir. Yes.
Done. So this kind of easy question will also be asked in your board, but not in JEE. JEE, they will give always tricky question. That's why I prioritize this second point for the question, but not the remaining one, because everybody can do this. Last. Then this part is over. Now we come to the physical property. I'll take the least time for the physical property because this is not something that will ask in a way that they can make difficult question. They can't. It will be always easy. So in case of either you take alcohol or phenol, you have OH. And when you are talking about OH group, so it means hydrogen bonding is one of the possibility. Right? If you
Yes,
talk
sir.
about boiling points, Chinmay, tell me what how boiling point change.
So does boiling point increase with branching?
Boiling point decrease with branching, but increase with if number of carbon atom increase, Chinmay, what
Yeah,
will be
sir.
the point?
Then the thing. I forgot, sir. Sorry. Boiling.
Boiling point will increase. And Smart, if branching increase, what happens?
Sir, if branching increases, boiling point will decrease.
Boiling point will decrease. Why?
The size decreases.
Size decreases. That's why you will see surface area will decrease. Got it? Because
Yes,
surface area will decrease, and if surface area decrease, there is a force known as van der Waals force.
becomes less.
Yes. So Chinmay, we discussed this in the last chapter, and at that moment I said ki it will be universal in every chapter. Do you remember?
Yeah. Yeah, sir.
It doesn't matter whether are you doing alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, amine, haloalkane, halogens, everywhere if carbon increase, mass increase, boiling point increase
Yeah, sir.
due to increase in the mass. But if mass is same and there is more branching, then surface area will be less, then boiling point will decrease. Smart, what is van der Waals force?
There it's the weakest force among two atoms, two molecules.
Correct, correct. Van der Waals force. It is the weakest force. What kind of force it is?
Attractive force only.
It is attractive force. Minimum between two body will always attract minimum with this force. It
Yes.
will always occur. It means if you have two body, like two human are sitting nearby each other, even they are attracting with van der Waals force. Though
Yes.
it is applicable to the atom or molecule, but still in the simplest language, it is the always attractive force between any two bodies. One of the weakest force, like nobody can feel it. It's like, Chinmay, can you feel gravitational force between two human beings?
No, sir.
Why? That's true. But why?
Yeah, sir. Don't know.
Smart. Why? What
So it's very
Chinmay
small.
said is correct. That's very small. And what is the reason of being very small?
So so the constant is small, 10 to the power minus 11.
Yes. Because G value, we
Yes, so
know
1.67
force,
into 10.
gravitational force is equal to G, M1, M2 by
By R.
R square. But G value is 6.67 into 10 raised to power minus 11
Minus 11. Yes.
coulomb square, right? So when this force is so less, now Sumarth, you tell me if you take two person each of 100 kg for easy calculation, and they are placed at 1 meter distance, what will be the value? 100 kg each.
6.67 into 10 power minus 7 kg.
Exactly.
Grades.
Isn't it very, very, very small negligible?
Yes, sir.
Yes. So that's the point. Here it is usually less between the two human beings, and that's why you will see gravitation force in case of extremely heavy body like between Earth and Moon, between two planets, two stars like this, right? If you see boiling point, in case of alcohol and phenol is high, what could be the reason, Chinmay?
Sir, phenols will have a higher boiling point.
Yes. Of course, mass is more, so
Yeah, sir.
phenol out of these two will have more boiling point. But overall, if you compare with the other molecule usually, except carboxylic acid, alcohol and phenol have more boiling point than other functional group. Functional group except carboxylic acid. So what is the special in carboxylic acid, Smart? This
Uh,
is not given here in this topic.
Sir, it is more polar.
So what?
The polar, like interatomic attractions will be high among plus minus groups.
Because carboxylic acid form dimers. Along with the hydrogen bonding, they have
Oh,
strong
yes.
dimer,
Okay, okay.
isn't it?
Yes,
Even strong dimer is so stable
yes, sir.
that they can form the individual unit. So, what is the reason, Sinhmar, why alcohol and phenol have more boiling point than any other functional group except carboxylic acid?
Yeah, sir. So because they have the capacity to form intermolecular hydrogen bonding.
I'm happy you mentioned intermolecular because most of people mention ki sir hydrogen bonding, which is not wrong, but we have to be very precise. This is
Yeah.
the complete answer. Intermolecular hydrogen bonding.
OH
Okay.
group is bonded to electronegative oxygen atom.
Yes. And same thing happen in case of example water. We have intermolecular hydrogen bonding. That's why water is present in the liquid form.
Yeah, sir.
Okay. So it means, example, if we have three molecules, CH3, CH2, OH, second CH3, CO, CH3, and third CH3, CH2, CH3. Tell me where will you have maximum boiling point? Both of you.
Sir, alcohol.
Alcohol after alcohol. This is more important. Alcohol is definitely hydrogen bonding.
Yeah,
What
sir.
about ether and alkane?
Sir, ether.
Why?
Sir, mass of ether is higher than.
No, mass is same in both cases. Calculate this. 17. This is 17. This is 16. This is 17. 17, 70, 34, 50. This is 17. This is 16. This is 17.
Oh,
Isn't it? So is this correct? Is ether more than alkane? Chinmay, what is your answer?
I'm not sure, sir, because you told
sir, polarity.
Yes.
Sir, oxygen is
Chinmay, you were
electronegative,
saying,
just like H2O.
okay, electronegativity difference.
Yes, sir. So partial uh, charges will exist in within the molecule.
Okay. Chinmay, you were saying something, sir, you told.
nothing, sir. I thought increase the number of carbon atoms will increase boiling point.
Yes, that's true. But here, mass is same. All three molecules have same mass.
Yeah, sir. That's what. That is wrong.
Answer is dipole-dipole interaction. Smart. Do you remember?
Yes, sir. Same in water also.
Yes. So in first molecule here, you have intermolecular hydrogen bonding. Intermolecular hydrogen bonding. That's why maximum. Here you have dipole-dipole interaction. Why dipole-dipole interaction? Because interaction. Because here oxygen will have negative charge, two negative charge. So it's like carbon will have partially positive charge. So there, because of this, they will have stronger bond. But here you will have only weak van der Waal force. Got it? Nothing else, only weak van der Waal force. That's all. Make sense?
So,
So can you explain the dipole-dipole interaction once again? I couldn't understand.
Yes. So in gaseous state, you will read about this topic. You have different type of force. Weak van der Waal force. Okay. Uh, weak van der Waal force, the simplest force is known as London dispersion force. Samarth, have you heard about this?
So they call a London forces, yes.
Yes. So London force Sinhmar is the simplest force where two non-polar molecules interact with each other when there is no pole, right? But tell me, if you have dipole, why? Because example here, in case of dipole-dipole interaction, you can see, example, this is CH3O and here CH3. Example, here you have two negative charges. So what will happen? This carbon will try to have positive charge. Same, this carbon will try to have positive charge.
Yeah.
Don't you think these two molecules won't act as a dipole as such?
Yeah, sir. Yeah, sir.
Same here, dipole.
Yeah, sir.
So because of these dipole, they will try to attract each other. Like positive charge will attract negative charge.
Yeah, sir.
And because of that, breaking this bond is difficult. So in interaction, because of the dipole presence, positive and negative charge pole is making this force to break difficult.
Yeah, sir. Understood.
It will be difficult for us to break this bond because of the dipole. Like how we have in the electric field, they will have attraction to each other. But just imagine you have another molecule. You have this molecule CH3, CH2, CH3. All carbon will have same electronegativity. So
Yeah, sir.
polarity chance is not there. Only because of mass they will attract. Here they will attract in case of ether. There will be London dispersion force as well as dipole-dipole interaction. But here only because of the mass, and because of the mass it is known as London dispersion force.
Yeah, understood, sir.
LD London dispersion force only because of mass, nothing else. Dipole-dipole interaction because of the presence of dipole, and there will be like stronger bond like hydrogen bond. Then last, solubility. Sinhmar, how solubility changes? First is boiling point, second solubility. Solubility is very small topic. How solubility change if you increase number of carbon? Solubility in water.
So yeah, sir. So phenols are soluble in water because they have the ability to form intermolecular hydrogen bond with water molecule. Number of
Okay.
so with number of carbon atoms solubility I don't know.
Smart. Solubility with increase in the number of carbon.
So solubility, the like dissolves like principle.
So will solubility increase or decrease?
Decrease, sir, with the number of carbon.
Always ask, sir, what is the solvent?
Oh, okay, sir. In case of polar solvents.
Water. Yes. In case of water, solubility will decrease. So your answer is right, but depend what is the solvent. If somebody, because most of people remember like this, number of carbon increase, solubility is decrease. But if they give what will be the solubility in case of chloroform, right? So, or CCl4, these are the non-polar compound. It means solubility will increase.
Yes, sir.
So solubility in water will decrease. Why? Because Chinmay, more number of carbon you are adding, it is non-polar molecule. Non-polar molecule are not soluble in water.
Water.
Example, fat. Fat contain 16, 17 or 19 carbon. So more number of carbon, that's why fat is not soluble in water. Because of this number of carbon. Okay. It means lower member will dissolve easily, but higher member
Dissolves.
easily in water, but higher member will not dissolve. So they will give you two compound. Example, if you have CH3, CH2OH, and then second CH3, CH2, CH2, CH2OH, and tell us where you will have more solubility in water. Tell me what is your answer?
So first one, sir, because
Exactly.
yeah.
First one. Then, so with this, preparation is done. If we have to make very small summary of what we did so far, it is just you can make alcohol from alkene, from acid catalyzed hydration, hydroboration oxidation, and oxymercuration demercuration. In all three, we take alkene and form alcohol. Second, carbonyl. In carbonyl, if you need reducing agent, you will see कि for aldehyde and ketone, you can use sodium borohydride, and for any higher molecule, you can use lithium aluminum hydride. Right? For most of, you can use lithium aluminum hydride, but it is a strong reducing agent, at the same time very expensive. Used for the esterification. No. If we are not using lithium aluminum hydride, then we are going for the esterification. And last, Grignard reagent. Correct? In Grignard reagent, if you have formaldehyde, then primary, any other aldehyde, then secondary, and ketone, then tertiary. Correct? If you are making phenol, then you can make phenol from the chlorobenzene. You can make from the benzene using oleum. Here doped process. Here using oleum, or from the aniline, isonium salt, and warm water, and last cumene using oxygen. Correct?
Yeah.
And if you talk about the physical property boiling point, increase with carbon increase, decrease with branching. And if you take solubility, the solubility will decrease with increase in carbon. Correct? It means solubility will increase with increase in branching. Now tell me how much time we took to revise this topic.
Less.
Few minutes.
Less than 2 minutes.
Yes.
Yes, sir.
This is what you should do while you are revising, not leaving any point, but at the same time, you are revising everything. What is the time? 2:44. Is it enough, or should we start the chemical property?
Anything.
Anything is fine.
Anything is fine.
Yeah.
But I understand chemical property we will start in the evening. I'll take class at 6 is fine for both of you. No, not 6, 7. 7 o'clock is fine.
Yes.
Smart.
Yes, sir.
7 o'clock. Just revise it for only 5 minutes after leaving the class, and that is enough. 5 minutes after the class today, 5 minutes before the class. Other than that, don't read the chemistry. Read other subject. Okay.
Okay,
And
yes, sir.
because yesterday and today was holiday, update in the group right now what you did in detail. Tell me one by one, Smart, what you did today from the morning on.
Sir, we had festival today, sir. So
Which one?
Sir, Diwali, we do it today.
You are celebrating today.
Yes, sir. It's not Diwali specifically. I don't know